What we are going to be doing today is again TF, but on what? 8.4, right? So everything else until now has been done, concept is finished. Now we start with the implementation on 8.4. The difference between 8.2 and 8.4, on 8.4 MPF redundancy, which includes the contexts, is the same. MPF is the same, redundancy is the same command, same everything, same way of processing. The context based failover is the same. Everything except for two things. One is transparent firewall, the other is NAT. NAT is completely different. Plus you have one more thing called port channels. This is an extended form of redundancy. It's an extended form of redundancy wherein two interfaces, remember in interface redundant, what we used to do, we had two interfaces. One was active, one was standby. So one interface goes down, the other one comes up. That was interface redundant. With port channels, what you can do is you have two interfaces, both will be active at the same time. That functionality was not there in 8.2, came into 8.4. So we'll have a look at that also.
Active.
Not active.
Load sharing.
Redundant interfaces. See, earlier when you had two interfaces connected to the firewall, connected to the switch. So we used to do these two configures, these two interfaces we used to make them part of one interface. Interface redundant 1. Then member interface E0 and E1. So out of this, if this is E0, E1, one of them would be active, one would be standby. This will not work at the completely, but when this goes down, this would come up. Remember, one goes down, the other comes up. Now with port channels, what you can do is, but the prerequisite is on the switch should also support ether channels. So from the switch here, you start an ether channel bundle, and from here also you bundle them together, right? So both become part of the same ether channel bundle. That is called port channeling. We'll do that, not now, we'll do that later. Right now, what you have to do is, today's topic is transparent firewall, on 8.4. The main concept is the same, the difference is it's a little more advanced. What do I mean by that? On 8.4 you have the capability on the firewall. See, 8.2 was only two interfaces allowed, inside, outside, one per network, only two interfaces allowed. In 8.4 per network you have four interfaces allowed. You can have DMZ 1, 2 per network. Okay, so this can be 10, 11, 11, 1, this can be .2, this can be .3, this can be .4. They'll talk to each other, right? One thing is that. Plus, apart from this, you also have another feature where on this, if you have this and this, two separate networks, you have two separate networks, you can make them go through the ASA. Earlier this was not possible. So now the ASA can have R1 and R2, and here R3 and R4. These two networks will have nothing in common. They'll be completely separate. It'll be like R1 is directly connected to R2 with ASA in the middle, and R4 is connected to R3 with ASA in the middle. Right, you have that functionality on 8.4. Let's see how. Let's remember yesterday's command. Let's remember them. What was the commands that we did on the firewall? We did firewall transparent. Then I went to interface Ethernet 0, name if, inside, no shut. Here you have to do one more command under the interface. That command is called breach group 1. In total you have 1 to 100. You can create 100 bridge groups. Depending upon different iOSs, we have different versions, but more generally you have 100 bridge groups that you can create. What about the other interface? Ethernet 1, name if, outside, no shut, and what bridge group? 1 also. Why am I doing this? I told you I can have 4, right? I also said that through this now you can have one network here, one network here. So if this is E0, E1, I'll make them part of the same what? Bridge. One bridge group, one IP address. So from this side I can have bridge group 2. This will be bridge group 1, this will be bridge group 2 with 4 different interfaces. Or I could make all of them part of the same bridge group, but in that criteria all of them should be on the same subnet. Same like VRF. VRF was doing this here, right? But this is layer 2 now. But the concept is similar. VRF, we divided one router into 2. So this part was going through a different router, this was going through a different router. This is doing exactly the same thing, but 2 different bridge groups. Now you'll say, yesterday we gave out IP addresses. Where do I give out the IP addresses? Can I do this? I could do that, but that would not be feasible. Why? Because this bridge group 1 is going to be on a different network. This bridge group 2 is going to be on a different network. This was okay yesterday because yesterday only 2 interfaces were allowed, inside and outside. Today it's not only 2 networks, it's not one network, it's 2 different networks. So I need this address as well as for the other end network I need 10, 22, 22. Right? But I can't do it like that. It'll overwrite it. So in 8.4, the way you give IP addresses is for each different bridge groups you have different IPs. For that you have a separate interface. It's called BVI, Bridge Virtual Interface. Which one? BVI 1 will be 10.1.1, and then BVI 2 will be 10, 22, 22, 10. Right? BVI 1 and BVI 2. So now, if you have a look at this, for this network, for the first network, the ASA will be represented as, for the second it will be 22.22.10. This is 10, 22, 22.1, 10, 11, 11.1, or this can be 3. This will be 10, 11, 11.4, 2. Clear? Interface BVI1 will be this IP address. Interface BVI2 will be this IP address. But for that, here also, I need to do something else. What is that? I did it for E01. I also need to go to 2, name if, inside 1, no shut, What bridge group? Bridge group 2, right? Interface Ethernet 3, name if outside 2, no shut, also bridge group 2. But here I also need to give my security level, because it's not inside, it's inside now, so it will not have 100 by default, right? So these two interfaces, different bridge groups, different bridge groups, different bridge groups. Everything else is exactly the same. Your app inspection is the same, your ACLs are the same. Nothing else changes except for this part.
I don't understand that dot 10.
Which dot 10? This one?
This,
Two IP addresses. See, earlier, yesterday, what did I do? Yesterday, I had only this capability. This was the maximum number of connections I could have. And these two were on which network? So the IP address that I give to the ASA for management was this, right? Today I have what? I have two different ones. I can have like this. This can be a different network. This can be a different network. Now, since I can have this to manage ASA, I need to manage it from here separately, from here separately. So I need to give an IP address where? In this bridge group and in this bridge group for the ASA. So in this bridge group, ASA will be some different address. In this one, it will be a different address. From here, I'll keep it as 10, 11, 11.10, and this guy will be 10. Is that okay? Clear? Everybody?
So only the bridge groups are given by IP?
Only the bridge groups. The bridge virtual interfaces. IP is given only on the bridge virtual interfaces. Earlier I didn't have a bridge virtual interface, I would just give it to the firewall. Now I can't give it to the firewall because now I need to give it per virtual interface. That is the only difference between 8.2 and 8.4. Is that clear? Good? Let's try to do this. It's pretty simple. I'll connect 4 routers. First I'll show you one same subnet. I'll put all of them on the same subnet. Yesterday I couldn't have more than 2. Today I'll show you I'll have 4. 4 is the maximum. I'll also have a 5th one, so you can see that I cannot have 5. E1, okay, start the firewall first. Let it come up. So do not confuse yourself when I do this. All of them will be which network? So how many bridge groups do I need to create? Only one. This will be part of one, this will be part of one, this will be part of one, this will also be part of one. But this I can't. I'll try, but I can't. Maximum can be only 4. Yesterday, 4 VLANs basically. 4 VLANs can be combined on 8.4. In 8.2, only 2 VLANs could be combined. Okay? Clear this off. ASA is up. Let's bring the routers up too. क्या मैसेज दिखाता रहता है तुम्हारे? हाँ? Script VB. I'll configure the routers first. No need router, I just need to check this. And R4. I'll also configure R5. That's all I did. Configure them with IP addresses. Now, ASA. First command is, before we go there, show version. The version I'm using is 8.4. Okay, so this is 8.4. Let's try what other things we can do. Again, same interface, Ethernet 1, Ethernet 1, name if inside. I can also call it inside. Inside, yeah, inside is fine. Name if inside, and I'll have no shut issue. Also, bridge group should be 1. I have to make it part of a bridge group in 8.4. This is the only difference. Interface gigabit 2. Name if outside, no shut, also bridge group 1. Interface gigabit Ethernet 3. Name if DMZ 3. Security level 50. Bridge group 1. 4. Name if DMZ 4. Security is 49, or I'll have 50. Same security level. No shut. Bridge group is also 1. I'll try it with Ethernet 5 also. Name if DMZ 3. DMZ 6. Okay. No shut. Bridge group not more than 4 in one bridge group. Okay, so no. One bridge group can have maximum 4 interfaces. No need for this guy.
How many pages can you do?
100 by theory. By theory 100. How many loopbacks can you create? Millions. How many do you create? No? That's the thing. By theory it's 100, but depends on how much load can your ASA take. You can create as many as you want to. Again, you need interfaces then. You only have 5, so you will need to sub-interface first and then assign them to different bridge groups. Okay, done. Now, if this is done, they should be able to talk to each other, right? Inside should be able to go everywhere. But he can't. Why? Tell me why. Security is fine. This is inside. This is inside. This is outside. This is DMZ. It's like this. Okay, not this. So why is this not working?
IP address.
The IP stack of ASA is down. I need to bring up the IP stack. How do I do that? Earlier 8.4 I used to do IP address. Here I can't give an IP address because everything is divided into bridge. I need to give it to BVI. It's called bridge group virtual interface. So BVI, which one? 1. IP address should be what? Can be anything, does not matter. Does not have to be 10, 11, 11, 1. Can be anything just to bring the IP stack up. But if you want to manage it, then you have to put it in the same subnet. Good. Let's try now. Open. How about R3? Can R3 reach? No. Something wrong with R3's configurations. Shut down. Okay. So there is communication between all 4 of them. All 4 can talk to each other. Again, from down to up, you'll have to apply access list. From up to down, no. If you want to go from R2 to R1, how would you do? If you want to go, I'm going from R2 to R1. It's not allowed. What do I do? Where? On the ASA. Incoming, outside. Let's do that. Conf T, access list, INF, permit, TCP, from host, 10, 11, 11, 2. To host, 1, equal to 23. Access group, INF, in interface. Okay, the concept is the same as yesterday, nothing different, nothing new. It's exactly the same, right? This is with 4 interfaces. Now I want to do the same thing with normal 2 interfaces, but 2 different networks. So what I'll do is, on this layer configure, or R1 and R2 will be 10, 11, 11. R3 and R4 will be 10, 22, 22. So I'll have them in 2 different networks. R3 interface FA00, IP address will be 10, 22, 22.3. No shut is already done. And R4 also the same. R5 also I'll put it in the same. 22 dot. So if you think about this is how it is. This whole portion, which one? No, not this. This and this is a separate entity, and all these three are separate, right? This I'll name it as inside one. This I'll name it as outside one. This will be inside 2. Outside 2. DMZ. Network here is 10 11 11 0/24. Remember, it's a transparent firewall, so the routers don't know that it's in the middle. 10 22 22/0/24. This whole thing, the whole subnet. Let's configure our ASA now. Tell me. Routers I just did. Tell me, which interfaces? Interface gigabit 1. The one is facing this. What should I do? Name if should be inside 1, right? Security level 100 and no shut. Also bridge group 1. Good. Interface gigabit Ethernet 2 is the one towards R2. Name if outside what? Outside 1. Security is 0, no shut. What else? Bridge group should be what? 1. So these two part of the same bridge group. Good enough. Interface Ethernet gigabit 3. Right? Name if inside 2. Security level 100. No shut and bridge group 2. Separate bridge group because separate network. Okay. Exit. Interface gigabit Ethernet 4. Name if outside 2. No shut. Also bridge group 2. Interface gigabit 5. Name if DMZ 2. Security level 50. No shut. Bridge group also. Will it accept? Will it or will it not? Each bridge group 4 interfaces. One bridge group 4 interfaces. It will accept. So it's not physically that the router, that firewall can handle 4. Each bridge group of a firewall can have 4 interfaces. Because each bridge group is a different network. Now if this is done, it will still not work. Why? I need to give IP to BBI 1 10 11 11 10. Done. Let's try R1 to R2. Open. How about R3 to R4? Will it work? Huh? Let's try. It will not. Why? Because the IP stack on bridge group 2 is not enabled. It's only enabled on bridge group 1. right? So I do need to get in here interface BVI 2 IP address 10.22.22.10. That's all. Okay, R4. I can go from R3 to. Is this clear? Any questions?
So the BVI2, the number 2 is associated with the bridge group number.
Yes. It is the bridge group number. Configure the bridge group number. Give it an IP. Good. So what you had yesterday was one firewall could only have one IP address and control only one network with only two interfaces with it. Now you can have as many as 100 networks. Each network can have 4 interfaces. Each network can have 4. So if you look at it from a practical point of view, you can have as many as you want, as many as your firewall can take, depending on the capability of your firewall. As many as the firewall can take, you can have that much, because 100 plus 4 interfaces per BVI is a lot. That's 400 interfaces that you will need. You only have 4. So how many sub interfaces will you divide? Right? Everything else from now on is the same. Everything else. Good enough?
We can communicate with
How does he know that it's given 10.22.4? Because of it has a MAC address table, right? With MAC address table, he remembers interface and MAC address, interface and MAC address.
It's given to 10 into 10, right?
Yeah. By itself, it's given to 10, but no one else will care about what this is. He will not tell anyone that he's to 10 into 10 into 10, 2210. But when a packet comes to 222210, then he will receive it. But he will not tell anybody else that he's 2210. Check this out. I'll say telnet inside telnet 10 11 11 0 inside 1, also inside 2. Right? 10 11 11 10 is what? The IP address of only for 10 11 11 10. But if he wants 10 11 11 2, check out, the IPs are different. See, 10 11 11 2 for him is also going through where? Through the firewall. But for 10 he's getting a different MAC address. For 2 he's getting a different MAC address. Why is that? Because 2 is represented by ASA for R1. So R1 thinks he's sending a packet to R2, but he's actually sending it to the ASA. But the destination header on him is of R2. That's how he sees 10 11 11 2 as 2's address. Although the next hop is ASA. So ASA switches, that's the job of ASA, between different VLANs. So this endpoint he will represent on the other side of his interface. This endpoint he will represent on the other side of the interface. So they think they're talking direct, but firewall is doing switching between them. Is this clear? Any questions in there, in here? Yes?
what about interrouting is
R1
R1 to R3?
to R3,
R5.
R5 to
R1.
cannot. R1 to R1 to R5 cannot talk. If you want to run routing, that'll be done using routing on a switch, not using the ASA. That'll be done from somewhere else. ASA will have a wide gap between them. These are two separate VLANs. ASA will not let them talk to each other. Okay, it's just like there's a wall between both of them. This side is separate, this side is completely separate. Okay, let's check other stuff.
If R2 is internet, some other public IP. will it communicate with all the two groups?
No. At that time you will not do this. That time you will not do this. This is done only if your resources are low. If you have low resources and you want to use one firewall to protect two networks, then you will use this. Right? Predominantly what you would do is you would put them part of the same bridge group, and this will be your internet. So one side internet and these are same part of the same bridge group. So this will be one DMZ, another DMZ, and this will be your inside outside. So they'll be going outside.
With
Different bridge group they can't. I'm just showing you that there is a capability. This is not a good design perspective. If you want to look at it, it's not, you don't look at it from a design perspective. I'm showing you the functionality of what you can do. In production environment, you'll do something like this. If you want to use one firewall to protect two, you do something like this. But in case you do have two different networks and you need to protect the two different separate traffic going somewhere else, you will use something like this, but no internet in this case. This will go to a separate network, this will go to a separate network. Yes, you could have something like this. For internet, you could have something like this. This eventually would be connected to another router, say R7, which would be connected to the internet. Right? So this will be natting on, this will be natting on, or this as a whole will be natting on here. Good? You understand the concept? Why do we use these bridge groups? Predominantly you will use the same thing which you used yesterday, but 8.4 gives you the flexibility of using more. 8.2 doesn't. Everything else is the same. Tell me now, did you do your EIGRP yesterday?
Yes.
I want to allow EIGRP between R3, R5 and R4. All three should run EIGRP. Tell me, what should I do? Where should I do what?
Access list on
Access list on. .4. What will I do? Access list. Access list INF. Permit what? From
Post.
Network 10 to
22.3 to 0.0. This is OBF, right? And
unicast.
also unicast. EIGRP host 3 to host 22.22.4 as well as on 5 because two hosts, right? What else? Same should be applied on INF. INF. From what source? 4 to 10, 4 to 3 and 4 to 5, right? Done? What else? What should be the access list? 5 to this, 5 to 3, 5 to 4, right? Try to apply these. Done. 3 for INF, 3 for OBF, 3 for DMZN. Access group INF in interface outside 2. Also OBF in interface inside 2. Another one DMZ2, but it's called DM. So I applied all three. Let's check and run EIGRP on R2, R3, R4 and R5. Good enough. All networks are here, right? All are coming through what? I have hit counts everywhere. But will my traffic go from R2, R3 to R4? Will I be able to do this? Will this work? You guys don't practice at all, don't you? Huh? Okay, 22. How about this? Will this work?
No.
Why not? Access list is applied. From where? See, inside to outside would be allowed, but now there's an access list which says permit EIGRP. It has also a deny any. That deny any will stop my actual data going out. Permit TCP any and permit UDP any going outside. Right? From here to here. Even from DMZ to outside. From DMZ to outside also. Make sure here you don't make any mistake. Because this access list is applied here. If you say permit UDP any, it will go out. You'll have to make sure that it goes out all over the place. TCP any and UDP any should be permitted out. In case then you require ICMP, you can do that, but generally ICMP is not allowed. So here I'll say access list OBF permit also on the DMZ. Okay, let's try now. Works. 5 also works. Hit counts 2. Good. Yes. Now if this is done, If this is done, this is all there is about 8.4 transparent firewall. There's nothing new. This is completely it on the transparent firewall. You also have an additional functionality which was introduced in 8.2 when 8.2 was released. 8.1 does not have that capability. What capability? That the firewall being transparent, they added the functionality to the firewall that it can also do natting. It can also do natting. So the only one thing that it can do now is a route lookup. Everything else it can do. That natting part which is not there is also introduced. Starting from 8.2. 8.1 does not have it. Okay. Now I would do it here on this one, but you have not done 8.4 natting, and there is no difference between the two. The way they work are exactly the same. Only the syntax is different. So we'll do this again on what? We'll do this on 8.4, 8.2 because you're comfortable with the natting of 8.2. The topology will be simple. Very simple. What? I'll have this. I'll have R1 on the inside, R2 on the outside. This will be a single network. You'll have to think about this a little bit. This is not a general natting process which you usually do. This is a little different. What do I mean by little different? I have picks here, I have this here. Inside I will connect to a switch. E2 connects there, E1 connects here. All of them same network. Right? What network? Now this will be my edge router. Connected where? To the internet. R4 is my internet. So this will have a public IP. The network is working fine, everything is happening, this is natting, R2 is natting on, and stuff is going on. Right? You don't need to use anything with the transparent firewall. What happens is your company purchases more IP addresses. More IP addresses, say in the range of purchase new IP addresses in the range of 170.1.20.0/24. Usually in production environment when you do this is your ISP, right? Change the symbol. This is your ISP, right? So he gives you this address. You have not assigned it to this interface. You already have a public address. You already have a public address to go out. But you purchase this whole block of address 170.1.20.0. What does the ISP do? Does he run routing with you? No. He runs a static route saying 20.0/24 is from 24.2. Installs a static route here. And then that static route, because it's an ISP, he puts it into the process of BGP, and this static route is thrown off on the internet. So everybody on the internet knows what address, 170.1.20. But when they want to reach this, they'll send their packet to whom? The ISP. The ISP will send this packet where? To .2. Because of this static route. He does not run routing with you. Except for special cases where you run BGP. This guy R4 never runs routing with you. He just has a static route pointing towards you. The question is, where do you use this address 172.1? I want to use it on these servers. These are my servers inside. Change symbol. This is one server. This is another one. I have two servers. I want to represent them using a dynamic address from here, a static address from here, on the outside. How do I make sure that's possible? See, I could do it with R2. R2 can do my natting. R2 can say nat inside this, outside this, and it'll work. But I don't want to do that. Why? Because I have a firewall already inside. If I have a firewall already, why don't I see? Firewall is not stopping any packets. Is not natting any. Is not routing any packets. I know the packets coming from here will always end up on R2. Why don't I make firewall, since he's checking my access list, at the same time change the source and destination, or the source of the packet, while the packet is moving through the firewall. I'll make the firewall do that. What? The packet, see, the packet will go from R1, obviously. The packet will be like 10, 11, 11.1, going to 200.1.1.1, which is on the internet somewhere. This packet will, the default gateway of R1 is what? What is the default gateway of R1? Not 10. The default gateway of R1 will always be R2, because this is not a routing device. This is like a bump in the wire. I told you yesterday, R1 knows nothing about this PIX. R1 thinks he's talking to R2. So he will send a packet to whom? R2. Generally what happens is R2 will change the source to 192.1.20 something and throws it outside, and comes back, changes it, throws it back. But since there is a firewall, and firewall is meant to do natting, is good at natting, what they do is they make the firewall change the source to 20.1, throws the packet here. He doesn't need to care about the source, he cares about the destination, throws it out to the destination, reaches wherever it goes to. The return packet comes how? The return packet will come from 200.1 to 1.20, 20.1. Return packet comes to the ISP. ISP says, oh, 20.0 is from .2. Comes back to R2. What happens here? What does R2 do? Does he know where 171.20 is? No. So on R2, you would have to give a route saying 172.1.20, 171.20.0 is where? On the firewall. You have to tell R2 specifically that this network is where? On here. So he forwards it where? To the firewall. He forwards it to the firewall. You cannot say it's here. You cannot say it's here. If you say it's here, it will become data plane traffic and it will pass through the firewall. You want to say this is where? On the PIX. Control. You want to tell him it's this. Why? Because when it reaches him, he will do the reverse NAT, change this back to 11.1, then move the packet where? To R1. You would require two routes here. One from here, a default route, because he wants to go to the internet. So this default route will point towards R2. From here as well as here. Right? PIX, the job of PIX is just to convert 10, 11, 11, 0 to 172.1.20.0, which is a public address. And from R2 will have one route for 170 to the firewall and one route outside. Default route outside because ISP. Confusing?
From R2, packet will first go to R2 and then back to PIX.
When? When you're sending from where? From here to here?
Yes.
When I'm sending from here to here, again the packet will look like 10, 11, 11, 1 going to 200.1.1.1, right? From here.
Yes.
Goes in, what is the next hop? R2. But it has to pass through the PIX. The PIX does change the source. And R2 doesn't need anything, it just needs a default route here to throw it out where? R4. Let's do it one step at a time. Let's do it one step at a time. What is the first step? My packet is going to be here. For this packet to leave R1, what do I need on R1? A default route. Otherwise it will not leave. Before we move there, let's do the configurations. Let's configure each of these interfaces. This is, by the way, in one of the exams. Transparent firewall and natting, because this is a little complicated. It's not simple NAT which you do on the edge and convert everything to the edge. There's a little bit of routing switching involved. A lot of routing switching involved. NATing is very simple, only routing switching. You have to be very careful where the packet is going. So I'll try to do it with the flow. If you don't understand it anywhere, just ask. Let's do it on R1 first. Interface FA00, IP address 10.11.11.0. No shut. I will not give a default router yet. R2 is the internet. Is it the internet? Yeah. Let's configure R3 first. IP address is 10.11.11.3. No shut. Should be able to talk to one because they are directly connected through the switch. These two have no problems talking to each other. Right? Finally, let's go to R4. This is the internet. I will not do any routing. We'll do routing together. 151.24.4. No shut. It will also have a loop back. 200.1.1.1. The internet. Okay. PIX will just be a simple transparent firewall. Firewall transparent. This is 8.2. Now remember, there is no BVI, no bridge groups, nothing. Interface Ethernet 1 pointing towards R1, which is downstairs. Name if inside. No shut. Interface Ethernet 2. No shut. Name if outside, and then IP address 10.11.11.10. That's all I need to do on the PICs for now. R1, I have not configured R2. Let's configure R2. Interface FA00, IP address is 10.11.11.2. No shut. Interface FA01. IP address is 150.1.24.2. No shut. Ping 24.4, which is R4, talking to R4 already. And R1 should be able to telnet into 10.11.11.2. I will enable 04. Let's have a look at what I've done. This is R1, R3 I've configured them, R2 I've configured with IP addresses, R4 I've configured with IP addresses. This is a transparent firewall configured with IP addresses only. So in the most simplest of terms, R1 should be able to reach R2, R3 should be able to reach, simplest terms, nothing special. My job is R1 should connect up to the internet, should go to 200.1.1.1. This is the job, using which address as source, anything from here. this should be used as the public address to go out. Okay, Akshay, kya kar raha hai? So let's start from here. R1, does it have a route to go to 200.1.1.1? Right now I have not configured any routing. So what do I do on R1? A default route, IP route 0000 10.11.11 dot. I have two options, either 10 or 1. 10 is the firewall, 1 is R2. It will always be R2. Remember, this is a bump in the wire. Only a bump in the wire. So default route will point towards R2. It will always go through the transparent firewall. Let's do that. 10.11.11 2. Okay. What will happen to the packet? Come up to the firewall. Reach the firewall. What is the purpose of the firewall? What is the job of the firewall right now? I need to NAT. I need to statically NAT the source. I need to change the source to 170.1.20.1. Say 1. Okay. Let's do that on the PICs. How you do it? Static inside comma outside. Outside address is 20.1. Inside is done. That's all I needed to do. So this becomes, oops, now the source changes to 20.1. Now since the firewall doesn't care about the destination and where the packet is going, he'll forward it out from this interface. The packet reaches what? R2. R2 checks what? Source or destination? Destination. Does it know where 200 is? I have not configured any routing. I have not configured any routing. I have to give a default route pointing towards the internet. Right? Because this can be anything. R1 wants to go to Facebook, so Facebook can be anything. So he should have a default route, because this is the edge, right? Default route pointing towards the internet. Where? On R2. IP route 150.1.24.4. So R2 should by itself reach 200.1.1. Good. So the packet will reach 200.1. He'll reach the destination. He'll be reversed. The reverse packet will come into the ISP. The ISP throw it out to R4. I need to give this route. I have not given it yet. I have to tell the ISP that 170.1.20 is where? Behind R2. Because R2 is the company which purchased this address from me. So I'll tell him from this public address which the company already had, they purchased another one which is 170, which will be behind R2. So the route that has to be given from R4 from the ISP's perspective is IP route 170.1.20.0. The next hop is 1.24. This is the ISP's perspective. So ISP will check this. See, alright, he wants to go to 170.1.20.1, which means 171.20.0, which belongs to my static route says it's from 24.2. So he forwards it to 24.2. Does R2 know where this is? 170.1.20. R2 doesn't know. Check R2. R2 doesn't know. He has a default route. He'll throw it back. So there'll be a loop. He doesn't know where this packet is. So what does he do? I need to give him a route. IP route 170.1.20.0 is from, I know it's from the firewall because the firewall did everything. So I'm sending it back to the firewall to change the source and throw it back wherever he wants to go. So this packet will move to the firewall. What will the firewall do? Change this part back to 11.1. Does he know where 10.11 is? He doesn't care, he just forwards it out. Switch 1 knows where it is, throws it here. Okay.
The packet come from R2 to AC.
How did it come to R2 to SA? I did a static route. I said 192.171.20 is with the PIX. I'm telling him that this is with the PIX. So he sends it to PIX. PIX changes it back and throws it back to R1. Okay?
But it is acting as just a forwarding device.
Not forwarding, it's just doing not netting. Whatever is passing through it is netting it. Whatever is passing, he's just netting. That's all it cares about. Does that mean my packet will go from R1 to 200.1 now? It does go through, right? And on the internet, Cisco login. Let's try again. What is my source? 170.20. 170.21. Now this is a server. I need to allow access to it from where? From the outside. Right? How do I do that? Where do I apply the access list and what access list do I apply? Where do I apply this access list? On the PIX. PIX is meant to apply access list and to do netting. That's what it's prepared for. What access list? Tell me. Access list. Access list. Permit. Host any to host 20.1. Permit TCP any equal to 23. In interface. On the PIX. Done. So R4 should be able to get into telnet 170.1.20.1. Okay. Similarly, on this I can say static. That's all I have to do now. Inside, outside. On the inside I also have 20.3, which is 10.11.11.3. Who's 10.11.11.3? R3. R3 I have not given a default route. So IP route 10.11.11.2. The PIX, not the PIX, the router R2. So now R3 should be able to go to 200.1.1.1. Let's check Xlate. I have translations. I have translations. Good enough? Good, right? Now what I want to do is I also want to do, see, now this is fine. This is working properly, but this is the internet. This is just the internet. Maybe I have a group of users who are behind R5. That also you want to use the internet. These people also want to use the net. Right? So start this. Let's start it. Let's console this. Out of T interface FA00 IP address is 10.11.11.5. No shut. IP route default route words R2. So telnet 200.1 dot, and it'll not go. There's only 2 addresses assigned. I need to NAT this guy also. So I'll go in here, static, inside, outside, 170.1.20.5, 10, 11, 11. So from 5 will be allowed to go. But this is a router now. Behind the router, I have a whole big subnet of 10.1.1.0. I have a whole big subnet of 10.1.1.0. How do these people go out? I need to do patting. I need to do patting. This I will tell you, but I will leave you with one thing. It will not work. You will have to solve that part. Okay? Patting I'll do, that's no issue. What I'll do is, on the picks, I'll say global outside 1 170.1.20. Say 20, right? NAT inside 1 10 110. Okay, I'll do this. So whoever is leaving from the outside interface, the source, this will be changed to this. This interface is PAT address. But it will not work. Tell me why. Not R1, R5.
R2 didn't know the route or kind of
R2 doesn't need, it's already translated by the time it reaches there.
It doesn't know the address of 10 dot, does not have root of 10 dot
10.1. What does pix have to do with this? See, the traffic will come with 10.1.1.1 going to 200.1. So it's coming here, default route towards that guy. The moment it reaches here, it'll change it to 20.20. Move it forward, goes to 200.1, comes back because it's going to 20. R2 forwards it to pix. Pix changes what? This part back to 10 dot. Does it know where it is? Doesn't know where it is. So it doesn't know which MAC address to use to forward it to. Usually it knew it was 10.11.11.1. So he would use the MAC address of 1. Or it was 10.11.11.2. 3, he would use the MAC address of 10.11.11.3. Right? But now he doesn't know. He doesn't know where 10.11 is. I have to tell him what is the next hop, where to send it to. Right? So basically a route towards 10.1.1.0. How? See R5. Right now not working. Where is my accelerate working? My accelerate is working. Right? It is getting patted, but when the packet comes back, he doesn't know where 10.1.1.0 is. So that's what I need to do. This is normal routing. 1.1.0. Where is it from? 11 dot 11.5. Route inside 10 11 11 5. So I'm telling him that to go here you need to go from this. Let's try again from R5. .172.1.20. Pure routing. NATing is very simple. I didn't do anything special with NATing. Very simple NAT. Yes? You might ask the question.
Routing
Also,
does not transfer it.
I'm not routing. He's not doing anything with routing. He's not taking anything from one network and moving it into the other network. He's doing everything based purely on MAC addresses. Purely on MAC addresses. He's not doing anything on IPs. I told you he can read IPs. He cannot take a packet from this IP and move it on to the other IP site. He cannot do that. His leaving interface was always the same, but he just needs to know which header to apply for frame so that it reaches R5. Leaving interface was always the same. Okay? The question that I wanted to ask was this. I forgot the question. So R1, yeah. What happens is, now you might ask the question, I don't know, none of you guys asked, is it possible that the firewall NATs and gives out this address range 150.1.24.0? See, I used a different address range. Is it possible that he gives this?
Yes.
Will it work if he gives out from this range, this link that you have? Why will it not work? It will not work. Why not? Yes? Think about it. Routing question. It's all routing. There's nothing. It's pure routing. Why will it not work? When you think about routing, don't go blank completely. I don't know what to do. There's only one way to check if the routing is correct. The most simple way of checking your routing is you start from the first device and you move on one device at a time. That's how you check routing. One device at a time. Start from R1, check the source destination, then move using the packet. Think. My question is, right now Pix is natting all the devices onto this separate address, which is 171.20, right, which was purchased from the ISP. Is it possible, because this is a link which is also purchased from the ISP, is it possible for all of them to be natted on to this link, but not using R2, using the Pix?
Routers both play within the same subnet.
Which ones?
R2s.
Which one will be in the same subnet?
R2, R1, R2. I mean, you should have a default route back to fixing 50, 20, or 50.
Yeah, but he will not have that because it's connected to him.
Yes.
Fix is not on the fix is in the transparent one.
No, that's not the answer. Check this out.
Be the transparent one
10, 11, 11, 1. Always check routing like this. My job is to do this, right? So default route pointing where? So no, I'm telling you. Listen. R5 is sending the packet where? To the internet. What is the next hop? R2. So goes. This is not a routing device, nothing. NATing is happening where? Here. If routing is happening here, I need to change my source. To what? Now it's changing to 150.1.24. Say any address. I don't care, 100. Right? That's all it does. Forwards it where? R2. Does it check the source? Doesn't check the source. Checks the destination. Makes a routing decision, sends it on to the internet. Goes to the internet. The return packet comes in from like what? Return packet looks like this. Comes back to the ISP. ISP knows 24.10. Moves it to R2. Does R2 know where 150.1.24.100 is? it's connected here. Will it ever forward it back to the PIX?
Will again forward twice.
It will be there, right? He'll be lost. He'll be looking for 100. He doesn't know where 100 is. That's where the packet will be dropped. Because if he was doing natting, he would know that the other address which he transformed it to. But he's not doing natting. Natting is done here. When the packet comes back in, this address is one of the interfaces of R2. Generally what would be the case is he should forward it here, then he would translate it back, because translation is this guy's job. But it comes in here with the interface address of F00, which he's not able to solve. He was not supposed to solve, he was supposed to forward it. But he can't even do that because it's his interface address. You're telling me that this is my interface, I should forward this packet somewhere else. That's not possible, it's my interface right here. I cannot even give him a route towards the PIX, because this is a directly connected route that I have, which is 0 completely. He will trust this route more than anything else. Yeah.
ड्रॉप करेगा कि वापस वो सेंड करने की कोशिश
Send क्यों करेगा? किसको भेजेगा?
ड्रॉप
नहीं. He received the packet. Why would he drop? नहीं. There will be no.
राउटर का दो इंटरफेस में एक सबनेट में होता ही नहीं.
Though interface cannot be in the same subnet now, so he'll drop it himself. He'll not send it because he received it from that interface. So he knows that the other guy doesn't have it. I need to find it. I don't have it, so drop. Good enough? Do you understand the routing concept of this? Why we use it on the PIX? This is the only one time you will use it. Not to do it on the edge, but if you want to do a separate NAT. For anything else, using a different address. Okay? That is transparent firewall with NATing.